Okay, we're going to go over the second part of Chapter 8, Section 3. And the first thing we want to talk about is how what it means to solve a right triangle. So when you are asked to solve a right triangle, you're asked to figure out all the angles and all the sides. Sometimes we are going to have information on the sides and no information aside from the 90-degree angle for our other two angles. So when that situation happens, we're going to use inverse trig functions. So an inverse trig function is what we're going to use to find angles when the sides are known. So let me show you, I'm going to show you two different, I love when we get to this place in trigonometry, because really all it is solving or plugging numbers into your calculator. So the hardest part is figuring out how your calculator wants the information. So if I have tangent of angle A equals 7/10, that looks like a little triangle, the little right angle. This angle here is A, and because I know tangent is opposite over adjacent, the opposite side of angle A is 7, and the adjacent side of angle A is 10, and our hypotenuse is right here. So when I have two sides and I want to find the angle, I'm going to take the inverse tangent or inverse cosine or inverse sine to find that missing angle. And let me show you how that looks. Mathematically, we write it as tan inverse of 7/10. So our angle A is equal to tan inverse of 7/10. So let me show you this is my computer calculator. My computer calculator wants me to input the number first and then apply the inverse relationship. So for this, if you're using a calculator on your computer, you just type in your value, hit the equal sign. If you don't hit the equal sign, it will take the inverse tangent of 10 and not of 7/10. So hit the equal sign, then make sure you're in degrees. You hit inverse, or for some students it's a second it's like a little 2 with the ND on it. We hit the inverse and we want the tangent. The little -1 doesn't mean to the -1 power, it means inverse. So when we plug that into our calculator, we get 34.99. We want to round this to the nearest tenth. So this 9 rounds this 9 to a 10, which rounds this 4 to a 5. So our answer is 35.0. Let me show you that same calculation just on, this is my Google calculator. So this one wants to have me put the sign in or the operation in first and then the number. So first thing I want to do is make sure I'm in degrees. I'm going to click the inverse button so I get those inverse trig functions. I'm going to go tan inverse, and I'm going to go 7 divided by 10 equals, and I get 34.99. So either way, you need to take a moment now, do the same process on your calculator, and figure out how your calculator wants you to input the numbers. It's better to figure it out now than when you get to the test and you have to have a learning curve as an assessment. So, all right, so the next problem that we're doing is the sine of b. I'm going to draw you one more picture just to show you that it's not a crazy triangle. So this is like 9 over 10. So the sine of b, so let's make b over here. That's our hypotenuse. So sine is opposite over hypotenuse. So the opposite of b is here. That's I just made this into a fraction. So 0.9 is 9/10. So that's like having 9 for your opposite side and 10 for your hypotenuse. Okay, so this goes in. It looks like this mathematically. Sine inverse of 0.9 equals angle B. And then I'm going to use my computer calculator. So I'm going to go 0.9 and then inverse sine, and I get 64.158. I'm going to round that to the nearest tenth, and that's 64.2. All right, I feel pretty comfortable being able to do this without drawing the picture. So if we have tan of angle C is 5.4, so they've already combined the fraction for us, the top and the bottom, and now it's already in decimal form, so that saves us a step calculating. So this is going to be tan inverse of 5.4 equals angle C. Pull our calculator up. We got, my calculator wants the number first, inverse tan, and we get 79.5085. I'll round that to the nearest tenth is 79.5. Okay, last but not least, we have cosine of D equals 0.1. So that's inverse cosine of 0.1 equals angle D. And that's, now that we're pretty comfortable, we just go 0.1 inverse cosine. Oh, it's 84.3. And that would be in degrees. All right, we're going to take this skill and we're going to apply it to solving triangles. So please remember, when you're solving a triangle has 3 angles and 3 sides. So you want to keep track of all 6 of those items. So I do that by making a list. So I got angles here, sides here. The one angle I do know in this ABC triangle is our 90-degree angle, but I'm missing my other 2 angles, which is angle A and angle B. And then for my sides, I know that one of my sides is 2, my other side is 3, and I don't know my missing third side. And in fact, I'm going to go ahead and solve for that missing third side. I know how to do that. I'm going to use Pythagorean Theorem to solve for that third side. That's a quick and easy calculation. So our third side, AB, is 2 squared plus 3 squared equals, we'll call this C squared, or C, equals C squared. So that's 4 plus 9 equals C squared. And then 13 equals C squared. I take the square root of both sides. And I get root 13 equals C. So I'm going to go ahead and put that in. And now I've got all my sides filled out. Now I need my angles. So the first thing I'm going to do for angles is figure out, let's find angle A. So when I figure out my reference angle, I always circle it. So circle the angle you're using sine, cosine, and tan on because it changes depending upon which angle is your focus angle. So when I look here, C is my hypotenuse, 3 is my opposite, and 2 is my adjacent. If I remember my SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. I have the adjacent side and the opposite side. So that is tan. So I'm going to say tangent of angle A is equal to the opposite side over the adjacent side. So for us, that means the inverse tangent of 3/2 is equal to angle A. So, and that's, once again, a calculator item. So I'm going to divide, because my calculator wants the number first. So inverse 3/2 is 1.5. Then I'm going to inverse tan that, and I get 56.3. I'm going to use the triangle sum theorem to find out what my missing angle B is. So I'm going to go, well, I know 180 minus 90 is 90. And I'm going to subtract 56.3 to find my missing angle is 33.7 degrees. Let's put degrees on here. 33.7 degrees. And then now I have all my sides and all my angles. This triangle is solved. Okay, so let's look at problem B. We're going to make the same list that we had before, our angles and our sides. In this case, I have two of my angles. I have that 90-degree angle and a 25-degree angle. So I can definitely find my missing angle using the triangle sum. And for my sides, I have this hypotenuse is 13. And I have side G and side H. These are my unknowns. So I'm going to make boxes for those. So here, we're going to just quick calculate this. This is triangle sum. So 180 minus 90 is 90, and 90 minus 25 is 65 degrees. So boom, I have all my angles down. Now I just have to find my sides. So we're going to circle our reference angle. I'm going to circle angle H. I always like to use given information when I'm calculating trig, because if I've miscalculated the information that or subtracted wrong or did anything wrong, if I go back to what the original problem said and use those numbers, I have a lower chance of getting the next answer wrong. So I'm going to go back to the 25 degrees, although I could use 65, I'm choosing not to, because what if I added or subtracted wrong? So when I'm using H as my reference, my opposite is little h, and my hypotenuse is 13. I'm just going to call this out, G is my adjacent. Okay, so I'm going to go ahead and solve for G. So I have the hypotenuse and I have the adjacent side. Hypotenuse and adjacent, that is adjacent hypotenuse, that's cosine. C is for cosine. So I'm going to say the cosine of my angle, 25, is equal to the adjacent side, which is G, over the hypotenuse, which is 13. In order to cross multiply, I put my cosine of 25 degrees over 1, and then I cross multiply. When I do that, I get 13 times the cosine of 25 degrees is equal to 1g. This is just a calculator chug. Got our cosine. We pull up our calculator here. I'm just going to go 13 times the cosine of 25, so that's 25 cos. And that equals 11.78. So we're going to say G, and I'm rounding, so got to change that to approximate. G is approximately equal to 11.8. Awesome, so let's fill that in. And now let's solve for H. So my reference angle is still the same. I'm still using 25 degrees, but now I'm going to use opposite and hypotenuse. Opposite and hypotenuse are sine. So I'm going to say that the sine of 25 degrees is equal to H over 13. Same process as before. I'm going to put it over 1. Cross multiply. And I get 13 times the sine of 25 degrees is equal to H times 1. And then we just start at a simple calculator check. 13 times 25 sine equals 5.49, and we are going to approximate that. We're going to round it to 5.5. So let's put that up in our list. .5. Okay. And that is all for solving triangles using trig and inverse trig.